All right. So my name is Eva Deelman. I'm from the University of Southern California. And Victoria talked a lot about, towards the end especially, about cyberinfrastructure. And she also talked about reproducibility from the point of view of a scientist. So in my talk, I want to tell you about a project that is piloting a Cyberinfrastructure Center of Excellence that aims to improve cyberinfrastructure for science. So we're looking particularly at large facilities and how the infrastructure can be improved to support scientific reproducibility, among other things. So when we talk about cyberinfrastructure, so the definition that we use is from Craig Stewart from Indiana University and others. And basically we're talking about something that consists of computing systems, data storage systems, advanced instruments, data repositories that are all connected via high-performance networks, providing as well visualization environments and everything put together to improve scientific research that would otherwise not be possible. An important part of cyber infrastructure are also people, and so that's something that oftentimes is not really mentioned very much, but is an important part of cyber infrastructure today. Victoria mentioned the report, so you actually have a picture of it here. And the recommendation that I pulled out of it was the one talking about infrastructure, that funding agencies and organizations should consider investing in research and development of open source, reusable, usable tools and infrastructure that support reproducibility for a broad range of studies. And so infrastructure is really at the heart of many scientific endeavors. And in particular, if we look at the large facilities that generate data that's used by a number of different scientific domains, we see that cyber infrastructure is absolutely critical to projects such as LIGO, that's searching for gravitational waves, as Michaela mentioned earlier, the radio astronomy observatories that are looking for exoplanets and other celestial objects, OI, which is an ocean observatory initiative that's looking at understanding our coastal systems, and Nyan, which is a national ecological observatory network that's looking at different issues in climate change and ecology in the US. And there are a number of, about 20 other large facilities that look at issues of high energy physics and others. So the goal of our project, which is a collaboration between the University of Southern California, University of Notre Dame, University of Utah, and IU and its trusted CI project that Van is going to mention, and Renzi. We want to develop basically a center that's dedicated to the enhancement of cyber infrastructure for science and is a platform for sharing and knowledge sharing and community building. And knowledge sharing encompasses a number of different aspects, including reproducibility. We want to be a key partner when these new large facilities are coming online or when they're enhancing the cyber infrastructure. Our work is also grounded in reusing what's already out there, so we're looking at promoting the use of tools that have been proven and are robust and are used in a number of different environments. And we also provide a forum of discussion, so we have working groups where people can participate and discuss particular items that are of interest to them. In our pilot study, so we are right now in year 2 out of 2. In the first year, we engaged the Nyan large facility to understand how these large facilities operate, whatever challenges that they have. And our overall strategy in that is that we first of all recognize the mission focus of these large projects. So the goal is to deliver data or computing in some cases to the scientists. So we engage with them. We really need to be mindful of that mission focus, and we need to and mindful of their time. So we want to engage with them in a way that's beneficial to them in the short term. We also know that they have a number of experienced people in the project, and so we also, in some cases, we provide advice. In some cases, we also rely on their expertise to give us advice and be able to disseminate it to other large facilities. In some cases, also we prototype some solutions. So if there are new technologies that are coming online, we can prototype them and see if they're applicable within a particular large facilities. But in general, we build expertise and not software. And in particular, we can recommend various activities or various types of development of cyber infrastructure that would support transparency and reproducibility. Currently, we're working with a community on a blueprint for such a cyber infrastructure center of excellence. So we want this to be a community-driven effort where people can give us advice on how such a center would be beneficial. Throughout this, we've been in partnership with Vaughan's trusted CI, the Center for NSF Center of Excellence in Cybersecurity, and we're looking at topics such as identity management and trustworthy data that really cross the boundaries between CI and cybersecurity. And we share personnel, and we also are leading joint working groups, and I'm going to talk about them in a minute. We also have a collaboration with Open Science Grid, where we share experience and expertise in data and workload management. And we also have been in discussions with Campus Research Consortium looking at workforce development issues and how these can be enhanced within the campuses in research computing, but also within the large facilities. As I mentioned before, our first engagement was with Nyan, the National Ecological Observatory Network, and they basically have these instrumental towers deployed within a number of ecoclimatic regions in the US. So they collect information about the air, the soil, and a number of different types of they collect a number of different types of measurements. They also have people doing field work and counting ticks on the mice and other type of collections at a particular site. They have both terrestrial and aquatic sites, and they basically collect this data, and they're supposed to collect it over 30 years and make it available to the scientists. So we've been working with them in a number of different areas. I'm just going to highlight one of them here. So we formed a data storage creation and preservation group, which aims at looking at how the data is collected by Nyan, how it is tagged throughout the system so it can be found and shared with others. And in particular, Chuck Vaderman, who is leading this team, was looking at how we can connect the Nyan data to the community efforts that are coming together around schema.org. So in particular, he was deriving use cases from Nyan and bringing them to the larger community, in particular ESIP, where they're discussing vocabularies for Geo Schema and how they can be used to describe data in various contexts. And in particular, the Nyan example was very useful to them to see the richness of the data that can be supported within these schemas. Some other types of working group that we had, so we had a data capture working group that looked at how the data is collected at the sensors and how it is processed, pre-processed at the sensor. For that, we developed some prototypes looking at the new technologies that can be applied within this context. We also looked at the data lifecycle and disaster recovery, and I'll mention this effort a little bit in a minute. It's a little bit different from what Victoria was talking about. It doesn't look at it from the point of view of the scientist. It really looks from a kind of a management point of view of the large facilities. And for that, we have developed various documents and webinars about best practices in terms of disaster recovery planning for these large facilities. Obviously, if they're producing data and have to maintain data for 30 years, disaster recovery methods are very applicable there. We also had a working group looking at data processing that's happening at the data centers, how they manage to process the data and make it available to the users. In this case, we found out that Nyan was using very interesting workflow management systems. One was Airflow and the other one Pachyderm. So in this case, we took information from them. We got their expertise in this area. Even though we have workflow management experts on our team, we were looking at how these new workflow management systems are working in their environment, and we generated an experience paper. We also had a data storage curation and preservation group, which looked at the schema.org, as I mentioned, and was able to develop recommendations to Nyan as how to describe the data. Another group that was interesting was the data visualization and dissemination, and there we looked at how Nyan is delivering the data to the scientists. So one of the data products that they have are aerial observation data, where they fly planes across the US and they take pictures of a terrain. Normally, they just deliver this data as files from the website, but with our help, we allowed them to visualize the data within the portals and navigate this data in a visual fashion so that scientists could decide which portion of the data they wanted to download. And obviously, if the data is processed in a certain way, and it is, looking at issues of how that data was actually produced is an important part of the whole reproducibility story. Another working group we've been engaged with Vaughan was on identity management and providing them with solutions in that area. And also we disseminating efforts throughout the community about engaging with the large facilities. If you look at from the point of view of why Nyan would want to work with us, so Tom Gobernson, who was our lead point of contact there, give us a slide looking at the benefits for them was the short ramp-up time due to the readiness to change. So obviously, if you're making any changes to cyber infrastructure, the people that are deploying it need to be receptive, and that's also applicable, obviously, in the area of reproducibility. So if you're adding on additional constraints, people need to be receptive to that. In terms of the Nyan, they also brought in the network of cyber infrastructure colleagues, and that's also an opportunity to bring expertise in areas such as reproducibility. They did upgrades of their systems, of their portals, and they basically, the people that were involved in the cyber infrastructure were excited about working as bigger teams. So Victoria mentioned the data lifecycle from the point of view of a scientist. Here we started looking at the data lifecycle across the large facilities from the point of view of processing data to be disseminated to the scientists. So, and initially we talked with Nyan, with LSST, which is an astronomy experiment, also with IceCube, which is a neutrino instrument in the South Pole, and LIGO. And we divided the data lifecycle within a large facility in various stages, looking at the data capture, where the data is captured at the sensor. And then there is some initial data processing, data cleaning that can happen close to the sensor. So on the towers, basically, you can have servers that are doing processing of the data. Then the data is shipped to a central processing data center, where there is some additional quality control of the data, but also new data products are being derived, so from the level 0 to the level 1 and up to level 4. And so there you can see, if you want to look at transparency of the data and be able to reproduce results, there need to be some tagging going on across the layers so you can interpret the data appropriately. Then the data is archived and stored and finally disseminated and visualized. Throughout this, obviously, you have data movement that's being performed across the various stages of a data lifecycle. And disaster recovery can also be viewed at these different stages. How do you recover from failures, for example, at the data capture sites, or at the central processing, or at the archival? And the question that we're also posing is, what are the services that correspond to this data lifecycle? So if we examine issues of reproducibility in the context of this data lifecycle for the large facilities, some of the questions that we want to pose are, what are the challenges and approaches to reproducibility that's happening today within the large facilities? What are the services that are deployed today to enhance reproducibility? So people are using, for example, in Nyan, they put the codes that are used to generate the new data products within containers. And obviously, there are some other descriptions that are needed to be able to support reproducibility at that level. What are other questions? What are CI services or service behaviors are needed to support reproducibility at different levels of a data lifecycle? And one thing that we might be considering doing in the future is setting up a working group so we can share ideas around these topics. In general, when we're talking about the activities of a Cyber Infrastructure Center of Excellence pilot and hopefully the center itself, we're looking at different types of engagement with the community. So we have the deep engagements with particular large facilities where we dive deep into particular topics and work hands-on on problems within their particular domain. We also lead working groups around topical discussions. So one of them is, for example, identity management. And we also started together with Trusted CI community effort around trusted data. So I'll mention that in a minute. We also have community building efforts. So part of us being here is to talk to the community and see what other challenges people have, either the infrastructure for large facilities, but also the people that are using the data from the large facilities, and maybe have ideas to contribute to the process. So if we were looking at what are the next steps for us, basically we're in the process of developing a blueprint for the Cyberinfrastructure Center of Excellence, and we're gathering feedback on the data lifecycle. So one of the things I want to do is connect more with Victoria and fill out some of the information and seeing the whole lifecycle from where the data is captured by instruments to when it's used by scientists. And we're defining new working groups as well. I mentioned the Trustworthy Data Working Group. So that's a group that formed 2 weeks ago, and it's led by Trusted CI in collaboration with Cyber Infrastructure Center of Excellence Pilot and other groups as well. Data hubs are participating in that. And the group aims to provide guidance on data security and for open science to improve scientific productivity and trust in scientific results. So this is very much related to issues of reproducibility and trust in data. And if you want to join the group, it's an open group, and the calls happen every Monday. And also we're doing a community survey. So if you want to look out for that, please go to this website. And I just wanted to conclude with a related effort. So in 2019, we had a workshop, NSF-funded workshop on cyber infrastructure for large facilities, and the report from this workshop just came out. And so we looked at various issues surrounding the CI for large facilities, and there were a number of recommendations in the report, including such that there needs to be opportunities for discovering cyber infrastructure and for sharing existing solutions. So that's applicable across a range of topics, including reproducibility. And there should be a common location for sharing best practices around various topics as well, use cases and others. So we're looking forward to connecting to these various efforts. And if you're interested in looking up any of this information, I'm leaving some of the links here. Thank you.